In this video, I'm going to show you how to get from where you know that this thing has a vertical acceleration downward of the 1.8288 times 10 to the 15th meters per second, how you relate that to the force, then the electric field, and then the voltage, the vertical voltage across these plates, the vertical change in potential. Okay, so the first thing we're going to do, this is really simple, okay, is we know that the mass of the electron is 9.11 times 10 to the minus 31st kilograms. We know that the acceleration is 1.8288 times 10 to the 15th meters per second squared. And so I'm going to use F equals ma, and I'm just going to multiply those. Okay, so 9.11 e minus 31 times the acceleration. Okay, is, and there we go, I'm getting a force of 1.66608 e to the minus 15th newtons. Okay, so there's that answer, right? Now we want to relate that to the force and the charge to the electric field. So I can use the fact that the charge is 1.602 e minus 19th coulombs. We know that the force is 1.66608 times 10 to the minus 15th newtons, right? And I'm going to use E as F over Q. Right, so there's my force. It's on my calculator. I'm just going to divide by the charge, 1.602 e to the minus 19th. And I get that if when I solve that for E, I get a solid 10,400. And that's newtons per coulomb, or it could more intriguingly be volts per meter, right? Okay, so there's that answer, right? Okay, and then finally, to relate that, we've got an actual voltage there, right? And what we're actually doing here is if this is an electron, that's a negative charge, we're deflecting that thing downward, and it's not gravity that's doing that, it's the electric field that does that, right? So if we want to deflect a negative charge downward, we make the bottom plate negative, positive. We make the bottom plate positive and the top plate negative. So we hook the battery this way with the negative side there and the positive side there, right? So that it displaces itself down like that, right? Okay, so the relationship here is that electric field is negative change in voltage over change in X, right? And I totally ignore that minus sign there because I've already figured out which plate's positive and negative. And so I want this, I know that the electric field is 10,400 volts per meter as well as newtons per coulomb, the same thing, right? And then I also know that my change in X is 8 centimeters, okay? Now don't confuse that change, so 0.08 meters, right? Okay, don't confuse that change in X with the change in X for the electron. For this thing, we're looking at the change in X over which the potential changes, right? And so now we're all set. The voltage is just going to be this times this, right? So this guy times that guy will give us this guy. So that times 0.08 is 832 volts. Yay.